Let's talk more about the invertible matrix theorem. Let A be an n by n matrix. The following statements are equivalent. That is, if one of these is true, all of these are true. And if one of these is false, all of them are false. A is invertible. The reduced row echelon form of A is I, the identity matrix. A can be written as a product of elementary matrices. AX equals 0 has only the trivial solution. So these were the four statements we had as part of the invertible matrix theorem, but we could add more statements to this theorem. A transpose is invertible because the inverse of A transpose is A inverse transpose. So as long as A is invertible, A transpose is going to be invertible. Each column is a pivot column. Why is that? Well, the reduced row echelon form of A is I, which means that every column of A is a leading variable, has a leading variable in it, and there are no free variables. Therefore, each column is a pivot column. Columns of A are linearly independent. Why is that? Again, it's because there are no free variables. The rows of A are linearly independent, and that's because if A is invertible, then A transpose is invertible, and that implies that if the columns are linearly independent, the rows are linearly independent. AX equals B has a solution for every B in Rn. Why is that? Well, because A is invertible, because you can multiply both sides of this equation by A inverse, and then you end up with X equals A inverse B. Columns of A span Rn. That's just another way of saying that AX equals B has a solution for every B in Rn. And the rows of A span Rn. Again, that's because if A transpose is invertible, then A is invertible, and vice versa. The linear transformation T of x equals AX is 1-to-1. The linear transformation T of x equals AX is onto. And again, all these statements are logically equivalent. If one is true, then all of them are true. I know it may seem tedious to have this huge theorem, this monster theorem with lots of statements, but it's the most important theorem in the course. We're going to use it over and over and over again. So I'd encourage you to know these. They're helpful.